So the only problem with this approach is that it's sometimes not all that easy to write numbers in their polar form, especially when it's like this. We don't just know the angle off the top of our heads, unless you've committed them to memory, in which case, well, good on you. But to do a question like this, we can use a different strategy to sort of get around it, and we just basically say, well, we know that z equals a plus bi, and so we use that and then equate coefficients. So using z equals a plus bi, I'm going to get z squared equals a plus bi squared, which is a squared, and then we're going to have plus 2abi, and then we're going to have minus b squared. So if I group the real and imaginary components of this, that's really a squared minus b squared for the real part, and then plus 2abi for the imaginary part. So I know that that's z squared, so now I can just put that equal to the original complex number, and so I can say that a squared minus b squared plus 2abi is equal to 8 plus 15i. And so using this, I know that a squared minus b squared must equal 8. And I also know that 2ab must equal 15. So all I'm going to do now is just solve these simultaneously. So I'm thinking I might rearrange the second equation here to get b equals 15 over 2a. And then I can substitute that into the first equation. So a squared minus 15 on 2a squared equals 8. Well, that means a squared minus 225 on 4a squared equals 8. I could, let's see. So I could multiply everything by 4a squared, and that's going to give 4a to the power of 4 minus 225 equals 32a squared. Alright, so we want to use null factor law here in order to solve this. So 4a to the 4 take 32a squared take 225 equals 0. I suspect that it's going to be 2a squared times 2a squared to make the 4a to the 4. And I think what will it be? So I'm thinking one of them must be plus 9 and the other minus 25, because two lots of negative 25 is going to be minus 50, and then two lots of 9 is going to be positive 18, which gives us the negative 32. So that's worked out quite well. So the thing here is that we actually have 4 solutions to this, but we're told initially that a and b are an element of the real number set. So I'm going to just ignore the part that's going to give me the imaginary solution, so I'm not going to worry about that first, not going to worry about that first bracket there, because that's only going to give imaginary solutions. So I can say that a squared, or actually I'll just jump straight in, so a is equal to plus or minus the square root of 25 on 2. And so I can get some b values based on this. I'll continue this up here. So when a equals the positive square root of 25 on 2, we're going to get b equal to 15 over 2 times the square root of 25 on 2. That doesn't really look all that nice, but it's a possibility. And when a is equal to negative root 25 on 2, we get b equals 15, well, it's going to become negative 15 over 2 root 25 on 2. And, well, that's more or less it. So what this means then is that from this information here, we get one of the solutions, which is z equals root 25 on 2 plus 15 on 2 root 25 on 2 I, because it's just a plus bi. And from this information here, we get the other solution, z equals negative root 25 on 2 minus 15 on 2 root 25 on 2 I. So there we have our two solutions. The other part of the question was to therefore factorize that polynomial. And so, well, I know that these are the solutions, so therefore I could say that z squared minus, what was it? Minus 8 take 15i is equal to, and just need to write these in their factor form, so it's going to be z plus root 25 on 2 plus 15 on 2 root 25 on 2i, and then the other is going to be z take root 25 on 2 and then take 15 over 2 root 25 on 2i. So there we have it. Anyway, I'll leave it there and see you all next time.